Welcome to a new test and teardown video. This time it's a Rohde schwarz Modulation Analyzer 55 kHz to 1.3 GHz. This is just typical Rohde schwarz with those really long numbers. Maybe there's a super sexy idea behind that. I just don't know. So I think this unit here is from about 1987, and it exists in 3 different versions. The base version is up to 120 megahertz, and then there's a 1 gigahertz and a 1.3. So this is the most upgraded version of them all, and it can of course do all sorts of analyze on modulations, AM, FM, and whatnot, and it can at the same time show the carrier frequency, RF input. See, it can be from 10 millivolts to 3 volts. So this is volts, not power. So be careful with that. So we need some sort of an attenuator if you're testing on transmitters. But I think this is a before the transmitter stage kind of thing where you want to analyze the modulation and all that kind of stuff. Maybe we can say auto or manual dial in the frequency, and this way tune in the frequencies and all that kind of stuff. So on the back there is a built-in fan, and you can use up to 1 amp, 230 volts. So look at that. I need to adjust the voltage switch. So that tells me somebody didn't use this for a lot of years. This is a very, very long time ago. We only had 220. Here we can see a little bit on the different options that is installed in this unit. And of course we got remote access with address and all that. What is that? Demodulation. We got stereo output. AM, and we got the reference frequency either in or out selectable, and that is more or less it. Yeah, I better open and look for lead capacitors or anything brown, blown up or whatever before I plug it in. That looks easy. So that was quite easy to get inside, and I really like the color-coded plug-in modules. It's packed with plug-in modules like this. But look at that. It's impossible for me to do anything dumb here. Should maybe remove this lid as well and then have a little look. But meanwhile, I tried to look a little bit at this one. Here's the power on-off switch, and it's not working. So I need to follow, maybe there's a long stick going all the way back to the power supply or something like that. This is something I need to investigate. Let's look a little bit more on the inside here. I just pulled 2 modules and we can see a lot of dirt and dust. And of course, this is where the fan is. And so all the nice dirty air gets in there and pollute everything. I just cleaned those 2 boards so we can have a tiny little look at what is going on here. But the first thing you would see, you probably already know what I want to say now. Those red RTE capacitors, and they're all over the place, they are notorious for cracking, breaking, exploding, failing, and leaking, and I don't know what. So, yeah. But so far, I don't find any of those even leaked or anything, at least from what I can see right here. So I need to open up a little bit more of the different modules and have a look. And it is beautifully designed, of course. This is German top quality. And we got a little bit of wires soldered here on the back, and then it goes to the other board, and they made it so it's actually possible to pull these boards. That is really nice and fine. That'll be all analog. You can see here some timing constants and filters, and yeah, you see all this. That'll be analog and filtering and things like that. And a little bit of interface chip. I think, of course, this is a microcontroller interfaced, and everything is done using some microcontroller. So we're looking a little bit for these and see what kind of microcontrollers we got in this. So this is, yeah, CNET Mesa. And again, high precision film capacitors, super accurate, and they will stay within tolerances for the next million years, those. So that is good. Oh, one more little annoying thing. This type of plastic here is just going brittle and fragile, and I really didn't pull this really hard, and it just cracked. And this is a potential problem. First of all, I lost this little metal thing, so it's down here somewhere, so I need to find that. But also, the color codes, they're essential for figuring out where to put the different modules. Yeah, so I'm not super happy about that. Now I need to go and find that little metal thingy. So this is the bottom view, and we can see all the different modules here in fully encapsulated metal shielded cases. Really, really beautifully made. And of course, if you want to pull up any of those, we need to unscrew the different cables and then take some notes and be sure that we do this right. It's also, we got some numbers here, so it says exactly where to put them, and I think that is pretty straightforward. I don't plan to pull out all of them, maybe just one or two just to have a little look, but it's just beautiful the way it is made, right? It's a little bit funny with this fan. See, it says 12 volt DC, but we got like 4 or 5 wires sticking out of that one. So it's a brushless, and then the wires goes to this little module right there. So this is the brushless controller. So back in the old days, you could get motors and fans like that. Today everything is just inside the fan, and you just give it 12 volts and perfectly fine and easy. But back then it was definitely different sometimes. I've seen these a few times. So here's the on-off switch that is broken. First I just tried to put it in some cleaner spray, but I think there's a little tab broken in here. So what I'm gonna do first, at least so we can proceed, and that is to stick in something through that hole. This at least will allow me to have the switch in permanent on. That is better than this kind of annoying thing, right? And then we can probably power it up and play. So yeah, I assembled everything, and I locked the on-off switch all the way in, and then it of course works. I'm ready to. I hear some little clickety click, and it's using 78 watts, and yeah, I kind of like that. Let's take and give it an input, and oh, that is cute. Look at that. So now it's locking to the frequency and dialing everything in. Oh, that is sexy. Don't you just love this rotating LED? Oh man, that is nice. And we are in AM, so what is it? So this is, it's correct with this. 1, 2, 3. We can change this. Let's do 1, 2, 3, 4, 5, 6. I just jumped the frequency up a little bit, so just to see if it's accurate or not. But I mean, we just got the most sexy looking frequency counter. I'm totally in love with this one. So what happens if we go for FM? And then it tries to lock for FM, and I should not have any FM, and now it's in hertz. So the resolution of this unit is just amazing. Just try to give it a little bit of FM. So this is exactly 1 kilohertz of FM. We can do some different filters. I bet this is if you're using some more complicated modulation schemes, and also you got the demodulated output on the back, so you can put this onto your scope and everything like that. We can also change the detector for phase or RMS and all sorts of things. I mean, it's really, really fascinating what it can do. So what if I put this, I can put this into relative, and so this is my reference. And it's a percentage of that. Or you can also have it in dB. How cute is then the relative of. We can also go to volt. I was expecting to be able to use this voltmeter, by the way. So let's see what happens if we. So this voltmeter is from 10 hertz to 200 kilohertz. So what if I change the input to 1 kilohertz? So here we go. Now I figured it out. So I got 1 kilohertz, and it says here the frequency of my audio frequency input, and I also got the signal level here. It is almost 1 volt RMS, and this is, of course, I just put my signal generator for 1 volt RMS. And now comes the cool thing. I can, of course, add modulation to all this, and then we'll also show all these things. Right now I got no FM modulation, and since this is a 1 kilohertz, let's go back. If I go to voltage, yeah. So look at that. So I want to play a little bit with this. This is absolutely amazing. So let's go to 10 kilohertz, and then it's, yes, that is correctly updated. So at 1 kilohertz, let's play a little bit with modulation. Frequency. Can I do that? So I should probably change the frequency to 100 hertz. Frequency deviation to 100 hertz. And then nah. What are we doing wrong here? So that means this is, of course, only working if your input is on RF carrier, right? So when you're using the voltmeter, it also says voltmeter. You go to the voltmeter, okay? And then turn off modulation, and then it goes accurate again. I really like this LED indication here, so you can. What can you do? What can you do with that one? Yeah. Yeah, I'm totally in love with that one. Anyway, what can we use this for today? Yeah, we can take our radio communication systems and we put this through a dummy load with an attenuator output, and then we can measure the frequency and, of course, all the modulation indexes and everything like that. And I bet we can use this signal generator here to generate the modulation in the transmitter, and then we'll get a nice stable readout of whatever is going on. Maybe we can take, see, here's my cable that goes here. So let's see what is coming out of this one. So how do you turn this oscillator on or off? Maybe there is a way to do that I did not understand, because if you turn on the different, you should get this up and running, right? I don't know. No luck. Maybe I just need to read the manual. But anyway, I think that was so much fun to play with this thing. And thank you very much for watching. Hope to see you soon again. Bye bye.